Finally, guess what? Deep Compositing and Cryptomatte are now native to Fusion 20, and I've been waiting for this for ages. Before we dive into the details, I recommend watching the following episodes that explain Deep Pixel. Once you're familiar with it, you'll understand the difference between Deep Compositing and Deep Pixel. But to have a clear understanding of what Deep Compositing is, let's consider DaVinci Resolve's Deep Pixel and Deep Compositing. Both technologies leverage depth data for advanced compositing workflows, but they differ significantly in scope and application. Deep Compositing stores multiple RGBA and Z depth samples per pixel, allowing each pixel to represent several semi-transparent elements at various depths. This enables highly accurate integration of CGI into live action footage, especially in scenes involving complex phenomena like hair, smoke, fog, detailed shadows, or volumetrics. It also overcomes common Z-depth compositing issues such as edge artifacts and allows objects to be inserted or repositioned at precise depths without requiring a full re-render. In contrast, Deep Pixel and DaVinci Resolve's Fusion uses a single Z-depth value per pixel to simulate depth-aware effects. It works in combination with nodes like volume fog, fog 3D, and depth blur to apply visual effects based on that depth information. However, because it only supports one depth sample per pixel, it lacks the ability to composite multiple overlapping transparent elements at different depths, something that is essential to true deep compositing. We will cover this in detail in another episode. Hi, I'm Shashwat. I hope you're having a really great day. Blackmagic Design just recently dropped its latest update, Fusion 20. It's still in beta, so if you're working on a super important project, I recommend that you continue using Fusion 19 and only use Fusion 20 for experimentation. But if you do decide to use it, proceed with caution as some features may not work as expected. First, let me introduce you to some of the new tools that have been added to Fusion. Now, this is a tool that compositors have long desired in Fusion. And now, Fusion has deep image compositing tools. So let's explore these tools. Go to Effects, Tools, Deep Image, and they've provided some standard deep compositing tools to get you started. They might add more later, but for now, this is all we have. Now over here, I have some loader files. This is a ladybird animation that contains deep image data. This is a background image with deep data, but with no color data. Finally, I have another background image that contains color data but no deep image data. I know this because when I check the settings over here, it says 1920 by 1080 float 32, indicating that this is a normal image file, a standard EXR file without any deep information. However, if I load the background deep, this float 32 changes to deep 32. That means that this file contains deep data and Fusion is reading this deep information. And over here in the format, there are two options for image output mode: flat image or deep image. Since this file contains deep data and deep image is selected, we are now reading the deep image data. But if I don't want to use this deep image data and prefer to use it as a flat image, I can simply select the flat image option. Now to do deep image compositing, first we need to combine the background's deep data with color, and to do that, we are going to use Deep Recolor node. Deep Recolor node combines deep image data with RGB multi-layer image. This node has two inputs, one for deep data and the other for color. Now connect the deep background to the background input and then connect the color file to the foreground input and load it into the viewer. Now the file contains both the color and deep information. Previously, you would have to use a position pass, correct it, connect it to a particle system, and assign expressions to create a 3D point cloud that is not animated. But that's a long process. Now, all we need is the Deep to Points node. Deep to Points converts deep image into 3D point cloud. This tool is useful for visualizing depth samples and offers a way to view elements in Z when incorporating them. Let's load the Deep 2 Points node and connect the Deep Recolor to the Deep 2 Points node and load it into the viewer. One thing that we need for this to work is a 3D camera. Now that could be a 3D camera that was actually used to create this image, or we can just rely on a normal 3D camera, a Fusion 3D camera. The moment we connect the 3D camera to the Deep 2 Points node, our 3D point cloud scatters in the 3D viewport. Now let's move this up. There we are. So this is our 3D point cloud data created using Deep 2 Points node. Now over here we have another image. This is an animation that has deep information. Now how do we connect this to our scene? Well, a normal merge node will not work. So Fusion has provided us with Deep Merge node, which merges 2 or more deep image nodes. So let's connect the Deep Recolor node to the background input of the Deep Merge node, and then connect the Ladybug Deep animation to the foreground input of the Deep Merge node. Let's load it into the viewer, and we have this over here. And now let's connect this to the Deep 2 Points node and load that into the viewer. And now over here we can see our ladybird in the 3D point cloud data as well. Now, suppose we want to move our ladybird behind this tree, or maybe all the way back there. For that, we're going to use the Deep Transform node and connect this just between the Deep Merge and the Ladybug Deep. So what we have here is just like any other 2D transform node. We can move it in the X and Y axis, we can move the pivot, we can increase and decrease the size. And if we switch this off, use size and aspect, we can manually scale it in the X and Y, basically scale it non-uniformly. This entire area is our normal 2D transform node. The way it differs from a normal 2D transform node is this part over here, which is Scale Z and the Translate Z. So right now our ladybug is over here. So if I move this in the Z axis, and in fact I can show you. See, now it's behind this book. And if we reset this, this is where it's supposed to be, near the mushroom house. And if we hold the Alt key while moving along the Z-axis, it allows for a slower, more precise movement. So now it's behind this book, and now it is out of the window. And now, let's move it somewhere so that it's easily visible and bring it forward. Right, now it's just behind the window, and now it's just in front of the window. And the Z-scale does the same thing, just scaling it in the Z-axis. Deep Holdout node creates a holdout matte using foreground deep image to occlude background deep image samples, either by removing them or by computing the value after occlusion. So let's load the Deep Holdout node and connect it in our node tree. Let's load this into the viewer, and this is what it looks like. This is creating a mask based on the position of the ladybird. So if I move the ladybird somewhere here, we can see that we have now masked the front of the tree. And if I move the ladybird backwards, now it is masking anything that is behind this tree. So when we move the ladybird, the mask adjusts accordingly, either occluding the elements in front or behind the tree. Suppose you have another object that you want to include in the deep composition. But this object is a normal image file. Now if you want to use this image in a deep composition, you will have to convert it into a deep image. And you do that by using Image to Deep node. Image to Deep node has an input for a 2D image. When connected, the image is converted into a deep image data and can be composited in a deep environment via the Deep Merge node. Once converted, the image now contains deep information. However, note that while the image gains deep data, it might not include Z-depth data. So if you create a Deep 2 Points node and connect it to this file, it will display a flat 3D point cloud. So to introduce depth, you can assign a Z-depth map to the image. For example, this Z-depth map was rendered from Blender, which outputs a grayscale image but with the lighter area in the background. So first, we need to invert the Z-depth grayscale using a bitmap node. Now the Z-depth has been inverted. The next thing that we need to do is, if you look over here, this Z-depth has a size of 2880 by 1620 and the original image has a size of 1920 by 1080. So we need to make sure that the resolution of these two images match. So for that, we are going to add a Resize node just after Z-depth node. Now, Fusion also provides a deep resize node for resizing deep images. For instance, let's assume that the ladybird image is 2880 by 1620 and the background is 1920 by 1080. So we would use the deep resize node on the ladybird image before merging the layers. Now, let's go back to the node tree and add a normal resize node. Connect this to the Z-depth bitmap with its channels set to luminance and the clipping turned off. And then finally, we will use a channel boolean node to assign the Z-depth to the correct channels. Now the image to deep node includes Z-depth information. And when we load it into the deep to points node, it shows the proper depth. But the whole issue with this thing is that even though the composition works, there can be edge aliasing artifacts in the Z-depth, which we can see over here. This occurs due to the edge aliasing issue in the Z-depth map. There isn't a perfect solution to this, but you can hide the artifacts by using the deep crop node. Deep crop node crops deep image samples using specified minimum and maximum depth values. It can also crop pixels using an input mask. Connect the deep crop node and reduce the maximum Z value to crop the extra background points. And we can do the same thing for the foreground using the minimum Z slider. Then connect it to the transform node and load the merge node into the viewer to see the improved result. Now, once we are done with the deep compositing, we might want to return to traditional compositing like color grading. So to do that, we need to convert the deep composite back into a normal image. And we do that by using the deep to image node. Deep to image node converts deep data into 2D image by flattening its depth samples and outputting a composite that is ready for traditional 2D compositing. Now, connect the deep merge node to the deep to image node. Let's load it into the viewport, and now we can see that this is a normal image. And then we can add a color corrector node for further traditional compositing. So these are the deep image compositing tools that Blackmagic Design has introduced in Fusion 20. Now, what is a multi-layer pipeline? Fusion can now intelligently handle multi-layer image workflows, including support for EXR files, stereoscopic 3D, and Photoshop assets. Basically, what it means is, suppose you have a multi-EXR file. You render it out from Blender or any other rendering software. And earlier, to use them, you would have to separate them into their own nodes, either manually or using Hobbs EXR separator. And what we get is a very crowded workspace. So the solution is the multi-layer pipeline that Blackmagic Design has now provided us. Like, to even view an emission pass, we will have to separate this by going over to the format in the inspector, then change the channels to emission RGBA. But now we don't need to do that. If we just need to view it, we go over here where we see the default, we click on the drop-down icon and select emitter. And now we are seeing the emission pass. And now the crypto material pass. And now the ambient pass, and so on. So even viewing this has become much easier for us. And so is the compositing. Now, let's add a glow to these lights. So let's load a soft glow node. Let's load the soft glow node into the viewer. Now, to use the multi-layer pipeline, all we need to do is go to the settings, and down here we get this new panel which is called layers. Over here in its input layer, we can select beauty, So now it's using the beauty pass to create the glow. And then we can control it. So let's increase the threshold and then let's increase the gain. Actually, let's just reduce the glow size so that we can actually see what's happening over here. Now this thing also works with the multi-merge node. So let's load a multi-merge node. Let's connect the background image to the multi-merge node and load it into the viewer. Now let's connect it once more. And now over here, we can see this one layer is connected. And down here in the layer section, instead of auto, we can say beauty. Now this is a main beauty pass. Now let's add once more. Now we have another layer list. Let's select that and let's change this into an emitter. Also, let's delete this soft glow and let's load a new one. So this is a new soft glow node and this is completely blank. Let's increase the threshold, let's increase the gain, and let's just slightly increase the glow size. And this time, we are not going to go to the settings tab. We are going back to the multi-merge over here and we are going to change the apply mode from normal to screen. And now we can see that it works. Now let's add it once more, and for this one, let's say we want to darken the shadows a little bit. So we change the layer mode to shadow and set the apply mode to multiply. And now we have a much more darker shadow. But we can see that now we have lost our glow over here. Well, that's alright. We can very easily correct that. We click on our emitter node. In fact, let's just rename all these layers. This is emission. Let's just call it emit. This is shadow. And this is beauty. So let's move our emitter on top of the shadow layer. There we go. Our emission is back. But now we can see that we have lost some reflectivity over here. In fact, let's go to soft glow node and let's just reduce the threshold so that this area stands out a little bit. Now let's go to the multi-merge node and let's switch on the shadow and we can see that we lose this. So how do we get this back? Well, let's connect this to the multi-merge node once more and we're going to rename it Reflect. And this time we're going to use Reflection Direct and we're going to select Screen in the apply mode. And we can see that it works just as well. We can adjust the blend parameter and this is our scene. So this is a very quick and easy way on how we can go about constructing our scene in Fusion with the new multi-layer pipeline. This makes our work a whole lot easier and faster, and this workflow also applies to Photoshop PSD files that contain multiple layers. Blackmagic Design has now integrated native support for Cryptomatte in Fusion. Previously, users had to rely on separate plugins from GitHub or Reactor, but with Fusion 20, you can effortlessly work with Cryptomatte files without any additional plugins. For example, over here I have two files, a background image and its corresponding Cryptomatte file. Let's load the Cryptomatte node by going over to the Effects, Tools, Mattes, and then drag and drop the Cryptomatte node into the node editor and then connect the Cryptomatte image to it. In the inspector, we can see the various features similar to other Cryptomatte plugins. The node includes a view layer that allows us to select various Cryptomatte IDs, example Crypto Instance, Crypto Material or Crypto Object. Underneath that, we have the view mode and it allows us to change the output of the Cryptomatte tool, such as colors, edge, beauty pass or the matte, which is a black and white image. An output to alpha option adds the matte to the alpha channel, so even if the view mode shows color or beauty, the matte remains available. Next, we have two ways how we can select a matte. We can either click on this picker and then click anywhere we want in the viewer. For example, now we have selected this book, or if I click over here, we have now selected this window. And using the minus, we can deselect it. And the selected Cryptomattes will be available here in the selected Cryptomatte list. So the Cryptomatte IDs create the matte, and if I go to Crypto Material node and then select this part over here, it gives us its material name. Same with the objects. Now it has an object name. And we can delete them individually by clicking on this bin icon over here. Another way we can select our Cryptomatte is if we go over to this pick button here, and this opens a new window. Now we can just search for the Cryptomatte that we want to use. For example, let's say we want to use this one and it is using Crypto Instance ID. All of these are actually using Crypto Instance ID and I can switch it. So let's say Crypto Material. And let's just say I want to select this mushroom. We press OK. And now we have a matte selected right there Instead of colors, actually let's just select matte and let's change the view layer to material node as well. There we go. Our mushroom layer is selected. Similarly, let's go over here and let's select this one. And now this vine is selected. So this is another way how we can go about selecting various cryptomattes. Finally, down here we have the buttons clear all or clear selected layer. So if we click on clear all of the matte layers would be removed. And if we click on clear selected layer, then only the matte specific to a particular layer should be removed, while it's going to leave the rest of them as it is. Now, all this is still in its early stages, and there is limited information available. Additionally, it's also a beta version, so there's bound to be some bugs and issues. However, this is the native Cryptomatte support for Fusion 20. In the Fusion 19 update, they added some cool new features like multi-merge and multi-poly. And guess what? In Fusion 20, they've got a brand new tool called multi-text. It's like having a magic wand to add or format multiple text layers all at once, right inside a single node. And before we dive into multi-text node, let's quickly go over what multi-merge and multi-poly node do. So here in the multi-merge, we can connect multiple nodes at the same time without needing to create multiple merge nodes. We can connect all of them in one multi-merge node. And with the multi-poly, we have the ability to create multiple polygons at one place as well as mix between them. With Fusion 19, they have introduced a new multi-tool, and this is the multi-text. This multi-text tool gives us a greater flexibility to add and format multiple text layers all within a single tool. And you can see we have two texts right there, and we didn't even need to create one text node here and another text node over there and then use a multi-merge or a manual merge between these two. I've got all of them right here. Also, I can change the layout. For example, right now it's using a point. I can change it into a box, and what the box does is that it creates a word wrap inside here. Or I can also change this into a circle like this. Now, I can either go to the layout and do this, or I can click over here in the add text row to add a text with a particular layout. So this is our normal text, this is a box layout, and this is the circle layout. So click on this and now we have a points text. Click on this and now we have a box text, and we can see over here that it also changes its icon. And if I click over here, this is the circle text. So this is the new multi-tool that's available in Fusion 20, and it's another game changer that makes our life so much easier. Now let's check another feature in Fusion 20, the dome light node. A dome light uses both SDR and HDR image to surround the scene with a spherical light map, similar to an environment light. To use it, go to Tools, 3D, and over here in the light section, we can see this new node that's been added, and it's called the dome light. Earlier this node was only available for USD workflows, but now we have one that we can use in our internal 3D system. Now, unlike USD dome light, although they both do the same thing, that is they use an HDRI to create an ambient lighting, but unlike the dome light, where we have the HDRI texture loader over here inside the node, we have to load the HDRI texture for the dome light separately. So over here I have an HDRI file that I downloaded from Texture Haven. Now we don't need to do anything at all. We just need to connect this to the dome light, and that's it. We now have a new dome light in our scene, and we can check it if it works by adding a 3D shape. So we have a plane. Now let's rotate the plane minus 90 degrees in the x-axis. Right, now let's add another shape 3D node. This time we'll use a cylinder. So let's load that into the scene. We will reduce its radius and change its height, something like this. Now also let's move it upwards. Now let's merge these two together. So press Shift Space, type 3D merge, and let's connect these two together. Let's also increase the size of the plane. Now let's give these two a texture so that we have a much better visualization of how this dome light works. So now we have a ground texture and we have a bark texture. Let's load the merge 3D node, and this is what it looks like. And right now it's pretty dull. So let's connect our dome light to the Merge 3D node and have a look. Let's go to the dome light node, and in the ambient, let's reduce the intensity a little bit. So we have a scene which is being illuminated by the dome light, but let's also reduce the specularity of the shapes. So let's go to the material node, and in the materials tab in the specular, let's reduce the intensity quite a lot. And we can see that the log is now being correctly lit by the dome light. Let's do the same thing for the ground plane. Finally, let's go to the dome light, and in the transform tab, rotate it in the y-axis. And we can see that the light rotates along with it, and our scene is now being lit by the dome light. Finally, there are improvements in USD volume rendering. Although the native support for VDB file is still lacking, we must continue to rely on the USD workflow. Hopefully, they will implement this feature in the near future. Fusion 20 also introduces several other features, including vector warping toolsets, tools for virtual reality workflows, and a color grade viewing feature. This last one is particularly useful when using Fusion within DaVinci Resolve, as it enables you to view color graded footage directly in your Fusion page. So in this episode, I have provided basic explanation of these new tools, and I will go into more detail on some of these features in another tutorial. But for now, this is it. I'm really glad that Blackmagic has given us these wonderful new features, some of which we have been wanting for a long time. So that's all for today. Please don't forget to like, subscribe, and ring that bell icon. Until next time, see you.